Hi, today Meha, Pratt, and I, Meghna, are going to guide you on how to use Tracker. Tracker is an application that allows you to analyze any video to obtain necessary data and graphs of the motion. It allows you to figure out the vector components of the velocity, acceleration, and other components of an object. This will be very useful for you in conducting experiments throughout your year in AP Physics 1.
The experiment that we will use today in our sample video will be recording of a motion of a pendulum, which will be an important concept when you learn topics like energy. The pendulum is essentially a stand with a suspended bob or mass, which oscillates from one amplitude to another. When the pendulum is at its lowest position, it is said to be at its equilibrium position and has the highest kinetic energy. In this hypothetical experiment, you would be calculating the instantaneous velocity of a pendulum bob when it passes through its equilibrium position.
The trends in this experiment you should notice is that the total mechanical energy of the bob remains the same regardless of its position in its oscillation. As in when the bob is at the top, it has full potential energy and zero kinetic energy. As it travels down, the potential energy decreases and the kinetic energy increases. So in essence, at any point in the oscillation, the total mechanical energy remains the same. Before we begin the experiment, it's helpful to consider some safety precautions. If you're lifting the apparatus by yourself, make sure to use both hands and stay away from the sharp edges. There's no other safety measures to be taken. Now we will proceed to conduct the experiment.
So here we have our pendulum. So what you want to do with it is you stretch it to an angle of about 45 degrees suitably and just release it like this without exerting too much force on it so that it doesn't snag onto the end. And also you want to calculate the velocity only under the influence of gravity and no other force. Also, don't exert too hard of a force because then its momentum will be too high and it will probably go over an angle of 180 degrees. So you want to avoid that. After the pendulum has finished a few oscillations, then just stop the recording.
Okay, so first I uploaded the video on here. So you can change the rotation you can right click it and then you can go to filters and then you say rotate. And then you can say 180 degrees and then we can close it. And so I can change it to zoom to fit. Alright, that's already there. And so now I'm going to change the slider so that the frame is like where where we start to release the ball first. And so since like when we were recording the video, like we kind of moved the camera, so like we don't have like a stable origin. So I'm going to move it to a point where it's stable. So we can either slide the frame or we can right click it and then we can say clip settings. And then we can do the start and end frame. So it looks like it's about 192. And we can start frame at 92, maybe. Okay. Oh yeah, so that looks about right. So like we can play the video and then see where it ends at again. Okay, that looks about right. And then so after this, we can do the calibration. So you click on track and then you click on new and then you click on calibration tools and then you go to the calibration tape. And so the default is the 100 and so you can increase it and like change the direction of it as well. So okay, so now we have to use the calibration tape to measure the length of the meter stick. So you can go to track and calibration tape and say visible. So I already measured it, but how you can change the length of it is by going to like one of the ends and you can adjust like the length of it and the angle of it. And the next thing that we have to do is fix our coordinate system. So we go to track again and then we click on axes and then I say visible. So you can drag this at the center and so put it at where the ball starts. So in this case, the origin of the ball is at when it's at the bottom of the pendulum. So that's where I put it at the center there. And so the next thing we have to do is actually track our data points. And so what we do is we say track, and then we say point mass. And then to record the points, you click shift, and then you select the actual data point, and then automatically moves. So you just have to keep recording this. And at the end, as you can see, like over here, you see the graph. So like the more number of times that you click, like you can see the pattern of the graph. Okay, so after we finish tracking all the points, this is the graph that forms. And so you can change the X and Y axis titles, but I didn't change it for this time because it's time and then X position, so that's fine. And then also here, it has a track of all the points you clicked on. So here's all the data, and you can maximize the screen, and then you can look at your graph, and here with the data points, you can do the same.
So now that you already learned how to obtain the plot from the points of the pendulum, so now you can just easily see what the instantaneous velocity of the pendulum bob is going to be when it passes through its equilibrium position, since you just correspond that bottommost point with the one on the plot. So for example, here ours is 8. So ours, we're just going to find the matching point on this graph over here. And so once you find this instantaneous velocity, you can also find the kinetic energy of the pendulum bob. So this will be useful for you, as we've said before, because in labs you'll be trying to find out or prove how energy is conserved. So you can find the energy of the pendulum when it was at its max highest position. When you released it, that would be its potential energy, and it will convert to kinetic energy over here. So you can use Tracker, as you have seen, for various experiments and to just understand physics concepts. Thank you, and we hope you learned.